today is we're going to kind of like dig deep into some Rust syntax, kind of like even more than like line by line, but like word by word, like key term by key term, and kind of understand what it means and talk about Substrate. And so to get started, I went ahead and wrote up a little something yesterday, which is not finished yet. So I'm going to apologize in advance for a couple of reasons. One, it's not finished. And two is because I'm going to share a link now, and then I'm going to tell you right now that this link is going to disappear later because I'm going to merge this into the master branch of this repo at some time. So I just shared the link that I'm talking about in the chat there for everyone watching live, and I'm going to share my screen in a second for sure. But just to kind of finish up, when I finish writing this, I'll merge it into the master branch of my repo, but I won't delete this original branch at first. I'll leave it there for like a week or two with like a big link up at the top that says like, hey, this is about to go away, so bookmark the other one or whatever. But just kind of like a heads up that this link, I'm telling you right now, is not going to be good forever. And if you try to follow it later and it doesn't work, just replace the branch name with master instead of Substrate Rust syntax, and you should find it. So that being said, you all should have the link, so hopefully you can look at it. And now I'm going to share my screen and just kind of use it to guide a little like introduction, where really what I'm going to do is kind of go over some of the things that I just said, and then expand on them. So really, this document is just something that I kind of wrote mostly for myself to help me understand the flow of this conversation today, but then I also figured it would be a really good reference for people who came. So that's basically what this first comment says, and that we're going to be using, and I'll just go ahead and open this link now because this is what we're going to be using as our guide here, the trait configuration trait. So let's just see where we are. So this is the code that we're going to be using for our guide, the trait configuration trait from the node templates palette template. So the link on that document takes you right here to this trait that I'm talking about that we're going to use to kind of guide this discussion of Rust syntax. And just to kind of orient you into where you are, I'm going to scroll up to the top. So you see that we're in our good old friend, the node template repo there, and we're in the pallets template src lib, and now I'm going to go back down here to line 16 where the link takes me to, and we'll go back to this document and kind of finish up with this little introduction. Basically, so all I was able to kind of get out yesterday is this introduction. I would say that this is more or less complete, and this is really the important part because this is kind of like the preamble to the discussion today, like kind of level setting the conversation so everyone kind of has the same point of view. And then after this, it's going to be more of like a guided code walkthrough, but I am going to go ahead and update this document with some of the specific things that we talk about in that guided code walkthrough. But really, when it comes to like the document as like a key learning resource itself, it's mainly this introduction that I think is the important part. So what I've done in this first paragraph here is basically just talk about what I was just saying about Rust being a systems programming language, and it being kind of complicated, and Substrate being complicated, and all of these different things. So that's basically what this paragraph right here is telling you. And before I kind of dig into this new stuff, does anyone have any questions or anything at this time? I didn't mention this specifically, but we have our little ask a question box down here. So if you have any questions, please use the ask a question box, and I'll make sure to get to them. And I'll be checking back here pretty frequently. Unfortunately, I don't have a host today or like a buddy to kind of help me look for questions. So I'll just be doing my best to kind of go back and forth. But do use this ask a question box here if you have a question of anything that I'm talking about. So the next part of this introduction that I want to talk about is we just kind of laid out this idea that we have a lot of different complicated systems in front of us. We have the Rust programming language, which in and of itself is a complicated new language to learn. We have Substrate, which is a complicated framework for writing blockchains that makes very advanced use of the Rust programming language. And then furthermore, one thing that I haven't mentioned today, but that I think probably most of you are familiar with, is Frame, which is kind of the standard Rust library for writing runtimes, which is another heavyweight framework within Substrate that uses even more advanced Rust concepts. And essentially, I basically think of Frame as its own programming language. Frame makes very, very heavy use of macros, which is code that allows you to write code. And that essentially is a programming language. So the reason why I'm being very careful to draw out these three boundary layers, Rust versus Substrate versus Frame, is because we are about to go on a journey, on a discussion, where we're going to talk about many, many different interrelated concepts. And in particular, as we go through this little journey right here, you're going to see that, unfortunately, us at Parity, we haven't always done a good job of choosing names that makes it easy for you to go on this complicated journey. And so that's why I'm trying to help make it easier for y'all. But so any time that you're learning about something new within Frame in particular, you're going to want to ask yourself, how is what I'm learning about a Frame thing? How is it a Substrate thing? And how is it a Rust thing? And understand those interactions and how they all work and those layers of abstraction, those boundaries. And if, maybe at some point you're going to need to understand, oh, I'm actually not working in Frame right now. I'm working in Substrate. And so maybe then you want to understand, is there an interface into the Frame runtime system for that part of Substrate? And then you still want to ask yourself how it relates to Rust. So this is why I'm saying that the introduction is more important to kind of have like words, because it's really these concepts that I'm trying to like get your mind right as we kind of get ready to go on this journey of exploring kind of complicated Rust syntax. No questions, good. Okay, so now let's talk a little bit more specifically about the trait configuration trait. So the trait configuration trait. There's the capital T trait and the lowercase t trait. And this is what I said what I meant when I said we don't always do a great job of making things easy for you. But this is actually, it's already been changed. It's just not like released yet. So what we're talking about today is the released code. And so we're going to follow this syntax. And we are going to, I really, really hope that by the end of today, this single block of code, which may look a little scary to you with all of these angle brackets and double colons and what the heck is this, like I hope that you'll start to be able to understand it a little bit more and maybe not fully understand it, because that's a lot to ask, but maybe you'll at least have a better understanding of the questions that you need to ask in order to understand it better. And if you walk away with that, then I think this is a success. So we're going to talk about this and we'll kind of go through some other pieces of code that relate to this, but this is really going to be kind of the main thing that we focus on for the beginning of this conversation. And so let's kind of go on this journey of Rust versus Substrate versus Frame for this idea of the trait configuration trait. Let's do it. So the trait configuration trait is a Rust trait. And you can see here that I link out to the Rust book. So I'm going to make this larger, but I'm not really going to talk about this today because this is like homework now. Like I've provided you the link. If you are an application developer like me trying to learn Substrate, you should have this bookmarked in your browser. You should read it first thing when you wake up in the morning and last thing before you go to bed. You should just know the Rust book like inside and out if you want to be a real Substrate developer. And so for right now, what we're going to talk about is a Rust trait, this keyword, this Rust idea that we're going to talk about. And what a trait is it's like an interface in other languages. And I list a bunch of different languages here, and I hope that you're familiar with one of them. And so you can kind of understand, like, okay, I understand what an interface is. And so like an interface, this is kind of like the more technical definition, I guess. It specifies the behavior without specifying how it's implemented. But really all that means is like an interface is just a place where you list function signatures. But unlike interfaces in other languages, Rust traits allow you to define this idea of associated types. So let's click out here. You see we're back at the Rust book, but we're a little bit farther down. Before, when we were just learning about what a trait is in general, we were up here in chapter 10 in the traits, defining shared behavior. That's what an interface does. It helps you share behavior. But now we're a little bit farther down here in this advanced traits. And in particular, we're looking at this idea of associated types. And again, not going to go through this whole thing. I still don't understand this completely. It's confusing. I've read, in particular, this right here. Any time that I'm writing a trait and I'm trying to figure out if I need to use an associated type or a generic, I have to come back here and read this to kind of get my mind right and help me understand. So let's go back to our document here. So what we're talking about is how Rust traits are very much like interfaces, and most programming languages, an interface is just a collection of signatures. But in Rust, a trait can have what's called an associated type. And as I just kind of mentioned, associated types are similar to generic types that you can use to parameterize the interface or the trait. But obviously they're different because you can also have generic traits in Rust. So this is just important to know that when we're talking about the trait configuration trait, which is a frame concept, this is kind of the layer of Rust that it lives at. This is what a Rust trait is. It's a way to define shared behavior, and we define that shared behavior through function signatures, generic types, and associated types. And here, this is how you learn more about that. So let's see if we have any questions about traits. Cool. Okay. So now we understand a little bit about when we may want to use a Rust trait. It's when we want to define shared behavior. So as we're kind of like, I'm going to pause for a coffee break. As we're kind of starting to dig into this and really understand why this code is written this way, we can begin to see, okay, so it's a trait, it's an interface. It's the purpose is to define shared behavior. Okay, that's helpful. Let's continue. Let's learn a little bit more. So the Substrate framework, it uses a number of interfaces in general, and if some of those are regarding the runtime, and I'm not going to get into what the runtime is. I've talked about that before, and maybe we can link out to that later. But here's a little more detail about that. So if you're not too sure what I mean when I say runtime, which I know it can be kind of a weird word, you can just follow this link in the doc and then go up here to runtime overview from this primitive section and learn a little bit more about what a runtime is. But for now, let's take a step back and think about what Substrate is. It's a framework for writing blockchains, and it wants to be very general and allow people to implement things in different ways. And so the way that you do that is with interfaces. And because it's written in Rust, we don't use interfaces, we use traits. And so the Substrate framework defines a number of interfaces that it expects any runtime, whether it's written in Frame or assembly script or C++ or whichever language it may be written in, it needs to compile down to WASM, and it needs to implement these interfaces. And here's a list of what they are, and you can read more about them. We're not really here to talk about what the interfaces are. It's just this idea that the interfaces must be implemented. And so going back over here, let's just continue through this section. Substrate defines a number of runtime interfaces. Hopefully that's kind of understandable now, to define the expected capabilities and the types that are going to be used by the chain's runtime system. And so you can see that, hash and header are listed here. And then if you follow these links, hash and header, you'll see more like where in code or in documentation these actually are. And so just like I said, as a Substrate developer, you should go to sleep reading the Rust book. Maybe you read the Rust book on Monday, on Tuesday you read substrate.dev, and then on Wednesday you read our Rust docs, and then rinse and repeat. Or give me some time and I'll give you some more assignments. But so I link out to the hash and header so you can see where these traits are defined. And maybe let's just take a second. This wasn't really in my plan, but probably a good aside, because reading documentation, that could potentially be a whole seminar of itself. The Rust docs, there's a lot of information packed into them. So I don't want to say that they're unhelpful, but they're not necessarily transparent to help you read them. So let's talk about that a little bit. So this is a Rust doc. It's documentation for the Rust programming language, just like there's Java doc or Go doc or whatever. And so just like any language is going to have, lots of different things like types, functions, classes, Rust has the same thing. And so one of the things that I'm not super in love with the Rust docs is that they use different colors to represent, these different things, like a trait versus a class versus a struct or whatever. But it's not entirely clear where you're meant to find a legend of what color means what. So you just kind of have to okay, I can see that this is a trait and it's purple. So therefore, anything that is purple must be a trait. So that is helpful. And now we can see, okay, output is a type and it is orange. So anything that is orange must be a type. Now, this is a little weird to me. I don't even know what this is. Why? Okay, so it looks like I would expect vec to be a type, but it isn't a type. It's a struct. I'm looking down there at the bottom, but here, I'll click over here. So this is a struct, and what we can see is that the struct is this kind of teal color, I would call it. So I'm not going to go through all of these, but you get the idea. The colors are important. So this is Rust docs for a trait, and this trait defines one associated type, and we will talk about this in a second. We're not going to talk about that right now. For now, just understand that the name of the type is output. This will come later. And this type also defines some required methods. And here you can read about these. So this is a function. This is the name of the function. It has one argument, and the name of that argument is input. And this is the type. It's a vector of byte arrays, and it returns this output type, which you can see is actually the associated type. So that's just a little aside about how to read Rust docs. All right, no questions. Okay, cool, very clearly. Sometimes no questions makes me a little bit nervous, but as long as you're with me, I'm happy. Okay, so that was a little aside about how to read, oops, let me open that back up. I closed this. Okay, that was a little aside about how to read the Rust docs. And the reason that we were looking at those Rust docs is because I was showing you where you can read the documentation and kind of actually see in real life these runtime interfaces that I was talking about. And the reason that I was talking about runtime interfaces is because we're trying to understand this trait configuration trait, which is a type of interface. And so we first talked about the trait configuration trait as an interface, and now we're talking about how Substrate uses interfaces to define shared behavior. And so now we can assume, as we're kind of making our way down this path, that if there are these core runtime interfaces that Substrate expects, and Frame is the standard library for writing Substrate runtimes, it must implement these interfaces. It has to. The compiler will make sure it does. And the Rust compiler is very good at that. And so these interfaces are satisfied throughout the frame system, these core runtime interfaces, but some of them are satisfied by something that's very, very similar and actually very, very related to what we're going to be talking about more deeply, more in depth. These interfaces are satisfied in part by way of the core frame system trait configuration trait. So let's see what I'm talking about here. So this is a Rust doc. We understand this a little bit better now. So we can start to kind of parse this out. You know, I'll leave you to do that on your own, but hopefully, again, you know the questions to ask now, like, what type is green? I don't know what that is. Oh, it looks like it's an enum. There we go. Just learned something. So we're looking at frame system. This is kind of like it's like if the standard library had a standard library, this is the standard library of the standard library, the frame system. And then this is the trait of the frame system. So we're going to be talking about the trait of the template palette. And I'm going to give a little teaser here. You can see that this trait actually, and maybe I know there are better Rust people in the audience than me. I'm not a very good Rust guy, to be honest with you. I don't know the right terminology to use here, but you can see that this trait like extends or implements the frame system trait. It includes all of its functionality. And so that's a cool thing to know, and we'll talk a little bit more about that. But for now, let's just know that there is this kind of frame system library, and it's going to satisfy a lot of these traits that the Substrate framework expects. Some of them are satisfied through the trait configuration trait, and in particular, the ones I mentioned before, hash and header are both satisfied. And the links here, oopsie. The links here, I think they should just link out to, yeah, they're like anchor links within this document. And so you can just see a little bit more, like it's a type, it's a hash, we'll talk about that. And then it gives a little description. It's the output of the hashing function. And then you can even see that hashing is defined here. So let's maybe getting a little ahead of myself there. So let's just kind of, first, let me check. Oh, questions. I love it. Okay. Okay. Correct me if I'm wrong, but it looks like someone else in the audience has written, if I compare C# to Rust, I got it. A Rust trait is generic interfaces in C#. But in trait, there can also be just variables in contrast to languages like Java or C#. It's not variables, Thomas. That's not really the right way to put it. It's really much more like a generic. It's similar but different. And I obviously, as I mentioned, I can't really answer it better than that because I still need to go and read about these things when I'm trying to learn this. So what I'm going to do is share this specific link, and maybe I'll share it in here too. Okay, so the kind of like, I guess the short answer to the question is no, The trait cannot define a variable. That would not make sense because a variable is an instance thing, you know, like there can be one of them. Um, that is never the case with an interface. An interface like describes how something works. So it wouldn't make sense for an interface to have a variable. As long as the interface exposes the function, you're good. It does. If it doesn't need the variable, we don't care. But it seems like you understand from C Sharp, which, by the way, one of my favorite programming languages, probably my favorite enterprise grade, strongly typed applications programming language. But anyways, you seem to be familiar with the idea that traits can be generic. You just need to understand that associated types are like generics, but they're different. And you need to read that advanced section in the Rust book to begin the process of learning more of how and why they're different and when to use them. Yep, I see. It looks like you're getting it. Yep, glad I can be helpful. Okay, so it looks like we have a question about Frame. Is it the standard library, but can it be changed? Yeah, I think that's a good way to kind of describe it. Standard library isn't like quite the right terminology. So we're talking about Frame. It's kind of like this cross between like a standard library and a framework. So it provides a lot of core capabilities for you. And then really what it does is it allows you to write custom logic on top of those core capabilities. So yes, I think it's more or less fair to say it's like a standard library that can be changed. And one of the reasons why that is because it relies so heavily on the traits, the instances. That's what allows it to be changed. As long as you have those required methods, required types, you can implement the bases in any way that you. Okay. Mateus, I haven't heard from you for a while. All is well in Brazil. Nice sunny year. I know warm down there in Brazil here. Okay, so what Mateus' question is. I'm going to use another language, C++, to build on top of Substrate. How to implement these core interfaces? Shouldn't I be able to import it like a DLL or something? Great question. So the first thing that you need to remember, I see that someone is saying Happy New Year. They're Happy New Year to you as well. The first thing that you need to remember is that Substrate runtimes, no, you would not use a DLL. You use WASM. Substrate runtimes compile to WASM. That's the format. They use WASM. C++ can compile to WASM. And so there is a team writing a runtime framework for Substrate chains that is written in C++. There is a team doing the same thing for assembly script because that compiles down to WASM. In fact, the assembly script guys are going to, spoiler alert, they're going to be coming on seminar sometime soon to talk about their framework. So Mateus, I would kind of think of it in two parts. If you need to think about either selecting or writing the framework and then using that framework to write the code. So let me show a little bit more details about where you can learn about this. I'm going to go to my favorite GitHub repository, Awesome Substrate. And in particular, let's look at a couple of different things. First, we have frameworks. This is not the one I'm looking for. Give me a second. It's a big repo. Let's see. Framework. I don't think. Okay, yeah. So here are some alternative implementations. These look like client implementations. I do believe that there are some other runtime implementations, but I only have the line chain one, the assembly script one, listed here. But I think that chain safe, I believe they're working on one in, well, I don't know. I think Soramitsu is working on a C++ one. Let's take a look. This is what I wanted. I'll go to the Kagome GitHub. So now let's go out. I know this may seem like I'm kind of just like browsing the web, which I kind of am, but it's actually like this is actually a really important skill of a developer is to just kind of know, like, especially like if you're learning new like open source development, like I would say I'm still learning this, but just kind of learning like how to help yourself to learn information, because the fact of the matter is that with open source development, like it's all just out there, like, and there is kind of the expectation that you do due diligence and like look for yourself to see what information is out there. So part of what I'm doing now is just kind of showing you like how I may go about trying to research things and understand them a little bit more. So Mateus was asking a question about how maybe you would write a Substrate runtime in C++. And so I went to the awesome Substrate repo because there's a lot of resources there. And I went down to the alternative implementations, and I know that Soramitsu is working with C++. And this is their Polkadot host implementation in C++. But now I want to see if they have a C++ runtime framework. So I'm going to go back out to their GitHub repository, or organization, I should say. And this is what we were just looking at, Kagome. And I'm just looking now. You see it tells you what language it's written in right there, Kagome C++. So now as I kind of scan through here, I'm just looking for other ones that are the same color and are also in C++. And I'm not seeing anything. So maybe I was wrong about that. Maybe there is not a C++ runtime framework. But I think there could be. So that was a bit of an aside, but hopefully that helps. Happy New Year, Mateus. Hopefully that helps, Mateus. So there's kind of these two things. If you want to use a language like C++ to write a runtime, basically you're going to want to use a framework. And then you'll need to use that framework to implement your custom logic. Sorry that I wasn't able to find the C++ framework, but I still hope that that was a little helpful for y'all. Happy New Year to you as well. Okay. Ooh, we got a question from Chevdor. I'm like legit nervous because, dude, you're like way more of an expert than I am, but let's see what I can do here. How do you discover interesting traits? For instance, a dev could totally work without ever deriving anything from debug, for instance. Probably not a great idea, but it's possible. Soon, Rust devs discover some interesting traits such as debug, display. Substrate defines many traits. How do you avoid reinventing the wheel by missing out on those? Any personal trick beside browsing the doc and seeing if a trait based on its name would be helpful? That's such a good question. Really, Chevdor, I believe that it is my responsibility, Parity's responsibility, to make that easy for Substrate developers. I can't solve the whole Rust programming language. Like I can work in my role as Parity developer advocate to interface with the Rust people, but I can mainly focus on Substrate and what we do at Parity. And so it can be difficult. Discoverability is a real user experience concern, developer experience concern, and that's what I live and breathe is good developer experience. And so it's my job to make it easy for people like you to discover these things and to make it easy for people to understand that they don't need to reinvent the wheel, because this is something that I'm constantly explaining to people. Like, hey, don't try to do that on your own. We've kind of already done that over here. And the fact that you're asking this question, the fact that I'm having to constantly explain this to so many smart people, it's not really an indication that this is really hard or people aren't smart enough to understand it or something. It's more an indication that we haven't done a very good job of explaining it. So I'm working on it, and this session right now is like part of it. I think that part of this journey is helping people just to understand how to read these really unfamiliar things, and that's like the first step in getting there. But yeah, we got a long ways to go, and I would really appreciate any help from anyone like you who is honest to goodness, much more experienced in all of this than I am. So great question. Thank you for all your contributions so far. Great to see you at seminar. Thanks for joining. And yeah, I love that question. I see you left some comments there. I'm going to read them. Little thought for GitHub. Who finally added this dark mode? It's too dark though. Did you read that article? There's a search like GitHub dark mode too dark, and like there was something about it that didn't feel quite right to me. And there's some UX people out there who like did research on it. I don't know. It's too dark. Okay, so you need to write a top 10 list of traits you must use. Yes, top 10s, people love a good top 10. It makes it really easy for people to understand things. Good developer experience, good suggestion. Okay, ooh, question on shards. Whew, this is not out of my wheelhouse, and touche, Shevdor. Users are never happy. That's the it's a never-ending arms race. Okay, but we have a question about shards, which is not something I really know a lot about, and not really what we're talking about today. But let's just take a look. Can we implement it in Substrate in the same way where Ethereum 2.0 is heading, to increase the number of transactions per second? I do not think that that is a productive path to take. Substrate and Polkadot have, I would say, rather fundamentally different architecture than ETH 2.0. So rather than like looking at something like ETH 2.0 and thinking, how can I implement this in Substrate? Yeah, exactly. Shevdor says the shards of ETH are parachains in Substrate on a high level. And I really think it's that on a high level part that's important. So getting back to what I was saying, rather than looking out at something like Ethereum and saying, oh, how can I do this in Substrate? Don't do that. Look at Substrate and say, what is Substrate encouraging me to do? And understand, maybe, if you want to do something like what you're trying to do, understand why ETH 2.0 uses shards. Like I said, I don't know much about it, but I think it's scalability. And then say, okay, so Ethereum 2.0 had a scalability problem, and they're solving it with shards. I wonder how Polkadot solved their scalability problem. And Shevdor got it. It's parachains. And so now you're, rather than confusing yourself by mixing concepts and layers of abstraction, what you're doing is you're really understanding why something was designed the way that it was, and then digging in to the mindset and the point of view that the framework wants you to take. Frameworks, by their nature, even unopinionated frameworks are opinionated. That's what they do. They make your life easy by adopting conventions, providing opinions. And so don't ever fight your framework. If you ever feel like you're fighting your framework, stop, go take a walk, write the framework a love letter, or pick a new framework, but that's a long answer. I'm not good at short answers, but I hope that helps with that one. Okay, great. I see some people commenting there. I love it. Continue to use the ask a question box for questions. And let's go back and let me see if I can remember where I was. So I think we basically finished talking about this Substrate section here. We talked about what a Rust trait is. Substrate expects the runtime to implement some traits. The frame system implements a lot of those, and maybe you could implement them in other languages. I thought they were in C++, but they weren't. But today what we're going to talk about is frame. So frame is written in Rust. It's like the core, whatever Parity provided runtime library. So now we're going to start digging what is this over here? Okay. Now we're going to start digging much more deeply into this. So like the core frame system itself, which you can, let's go back to the Rust docs here and just one more quick aside. These are the Rust docs for the frame system, but this takes you to this trait that's called trait that's been defined within this. So if you want to see all the docs for frame system, I'm just going to show you that one more time because this link isn't always, super apparent. Just going to click back out there, and now you can see all the docs for the frame system. And this is where it gets a little bit more helpful, is you can see like, okay, modules are like mustard, I guess, and mustard M for modules. Structs are like teal, you know, You can do it. Okay, so let's see. So like the core frame system itself, individual frame pallets must define a Rust trait named trait. And so now we're finally getting to the code. We're looking at the template palette, and you can see that sure enough, we're defining a Rust trait named trait. And now let's start to dig into this syntax, like I said. So let's look at how we define this. It's public. So if we did not have this public keyword here, pub is a Rust keyword. If we didn't have that there, the trait would not be available outside of this file. And obviously a private trait is not very useful because you use a trait to define shared behavior. And so if you're not going to make something public and share it with other people, it doesn't compute. So again, really understanding all these layers helps why you can be like, well, duh, of course it's public. And so this is a Rust trait, and it is named trait. That was not a good decision. It has been rectified. Let's dip down in here, and I mentioned this. And so in particular, there's this pull request here that you can look at, and it was renamed to config. So in Frame 2.0, which is coming out soon, and we're going to talk about at seminar, not next week, but the following week, you'll learn all about this, and you can see that this looks much better. Pub trait config. So that makes it, I hope that provides you guys a little bit of a better user experience. That was something I spent a lot of time crowing about. So hopefully that pays off. Okay, so we are looking at a public trait called trait. And so now, as the Rust programming language is parsing this, it's going to expect certain things, and, and you need to understand how to read the syntax as well. So if you're defining a trait and you have a colon there, then anything that comes after that, it must itself be a trait. We know that the frame system trait is a trait. So you couldn't put a struct or an enum or a data type or anything like that here. You can only put a trait here. And so it basically tells you like the traits that your trait that you're defining is going to like extend or inherit from or whatever. And then if you want to define more than one of them, so you can have like multiple inheritance, it's more like composition, I think. I'm not getting the terminology right. Read the Rust book. But if you want to define multiple of them, you separate them with a plus sign. So it could be possible here to have multiple of these listed, and they would be separated with a plus sign. And so what this means is that everything inside the frame system trait is going to be available within this trait. I think as I'm talking about this, I think composition is the right term to use. So this trait composes this trait, and so it includes all of its members. That means associated types and functions. And again, if you want to ever refresh your memory, what's in the frame system trait, how do you do that? You go to the documentation for the frame system trait, and you look at what it's got. Okay, so let's go through this. So we talked about the fact that not a good name. We changed it. Going to be updated. We're using the term trait though. Okay, here is something that I think is really important to point out. In frame, and remember, I'm kind of jumping ahead of myself to this paragraph down here, but remember that at the point that you're talking about a programming language, and remember I said that frame is basically a programming language, at the point that you're talking about a programming language, there's some things that you have to just accept. Kind of like what I was saying about if you feel yourself fighting your framework, like go home. Why did the writers of Python decide to use white space? God, I don't know. I hate white space languages, but it's just a decision that they made, and it's just the way that it is. And if you want to use Python, you got to write the code that way. And if you don't want to write the code that way, then I would suggest you don't use Python. That's kind of the best I got for you. And so one of the conventions that Frame adopts, certainly in Frame 2.0, is the trait configuration traits. They only define associated types. Now, I don't know if I have actually seen that like written down as a rule everywhere, but I have never, in all the time that I've looked at Substrate code, ever seen a trait configuration trait define a function. They only define associated types. So let's see. Now let's go back here. We're going to look at this one, the frame system trait. Let me see if there's any questions. Yep, we got some questions. Okay. I'm not sure I'm asking the right thing. That's cool. How to call mod or something from a different file. Like if we want to make something dynamic, for e.g. in this tutorial, using Genesis config dynamically. Okay, that is not a correct question, but let me continue. If I need to make it dynamic from runtime instead of statically typed in, okay, yeah. So the Genesis config, the chain spec, is a static thing. It defines block number 0. There is no block before it. There is no runtime to call into. It is a static thing. You can maybe have some code that would like calculate some stuff for you, but at the end of the day, it needs to be static, and you need to define it in that chainspec.rs file, and it defines what the first block is going to look like. And then after the first block is created, you can start making transactions and update the state and that kind of thing. So dynamic Genesis config, I don't really understand what you're talking about there, basically. Yeah, and then in terms of like making functionality from one file available in another, I'll get there. So I may like come back to this a little bit, and I can show you how you can call functionality from one palette in another palette, and then I'll even give you some resources to learn more about that. But that's kind of jumping the gun a little bit. So I'll get back to that, I think. Okay, another question from Mateus. It changed from pub trait, right? So talking about how it changed, but frame system is something from no. Frame system is written in Rust, but frame system is the core of the frame runtime framework. So that means that it doesn't even make sense for frame to exist outside of Substrate. So Rust is a programming language. Substrate is a framework that is written in Rust, just like React is a framework that is written in JavaScript, or like Bouncy Castle is a cryptography framework that's written in C#. So we have Rust, the programming language, Substrate, the framework written in Rust, and then we have a framework within a framework, which is Frame, which is written in Rust because it belongs to Substrate, but Frame would never make sense without Substrate. So you could never say that Frame system belongs to Rust. Frame system belongs to Frame system. That would be like saying, does the key and value of a hash map belong to Java? No, the key and the value of the hash map belongs to the hash map. It's a concept that exists within the hash map. And you're going to use Java types to define the key and the value, but this is a very important point, and it gets to one of the very first things that I talked about, which is understanding these different layers. So frame system is written in Rust, but in terms of where it sits, I would say definitively it sits at that bottom-most frame layer, because it's like the core library of frame. I am sure the code I'm asking to understand why config does not use, not really understanding this last part, Mateus, why config does not use the frame system trait. They switched the name from trait to config because that was the choice they made. It would be like if the Python developers decided, we're going to decide to not care about white space anymore. That would obviously be a very disruptive choice, and people would probably freak out about that. But this is a choice that we made because we thought that it would be better. It would make our developers happier. It would make our code more clear. And so that's the reason why that happened, because it was a design decision that we made, and that's the way that it is. And I really, really hope that you like it. If you do, let me know. I love hearing that. If you don't, also let me know. I can try to make it better. But yeah, that's kind of how it goes. Awesome, great. That is a great graph, Alejandro. I love this or this like diagram here. So Alejandro just shared a link. It's not like not 100% what we're talking about, but I believe that every Substrate developer should just understand these three things like the back of their hand. It will really help you like understand what frame is. I mean, this is really, I would say, kind of like the next level advanced step to what we're talking about now, about understanding these boundaries at the syntax level. Once you feel like you're getting a little bit of a better grasp on that, come out here. And I feel like a really good way to like kind of self check if you're kind of there with Substrate development is if you really, really get the difference between these three things that are laid out here. So really good link, Alejandro. Thank you very much for sharing that. Okay. So let's see, we're back out here and we're talking about how Rust, the frame trait, configuration trait, it's only used to define associated types, not used to define function signatures. And so now let's look at the core one, the one that we are composing in our palette. And we can start to look at the types and just kind of see like, and let's understand, like, so we're defining an interface for a runtime system. Imagine this is called configuration. It's like the configuration interface for the runtime system. And so the runtime system needs to have some concept of a block number. The math seems to check out. That makes sense. I can grok that. I can understand that. The runtime system needs to know about some hash type, the output of a hashing function. And then we can even say the hashing function itself, I mentioned this before, I was kind of jumping ahead of myself. The hashing function itself is kind of this like generic interface thing. We need this type that we can use to hash things that's going to output this hash type, but we don't really care about what it is, but we can understand like, oh, sure, we need to hash things inside the runtime system. That's a very important thing. So it makes sense why that would be part of the trait configuration trait. Same with account ID, headers, events. Hopefully this is starting to make a little bit more sense now. And now let's continue to dig in here. So each of the trait configuration traits associated types are themselves described as a set of trait bounds. And I link out here that talks a little bit about what's meant by a trait bound. But really all a trait bound is it says like, you got to implement this interface. So it's like a way of describing the capabilities of a type. So the configuration trait defines a number of associated types, and we describe those types by the traits that they implement. And in Rust, we call that trait bounds. And so now we'll start to dig into this stuff that I said. We'll get to that later. So we're talking about Rust syntax, so I want to make sure this is really clear. And actually, let's go back here to kind of look at real code. But you can see that this terminology or this syntax right here, it's it's like identical almost to this. And so it's just a different way of looking at the same syntax, but I want to look at it in context here. So we are defining a public trait. We are calling it trait, which we already know was a bad decision. We want this trait to be composed of the frame system trait, which we learned a lot about. And now we are going to start defining this trait with this, that's what these curly brackets mean. And a trait could have associated types. It could have functions. In this one, because it's the frame trait, we're only going to do the associated types. And we can even read here. Someone, I wonder who it could have been, left a very helpful comment here. Because this palette emits events, it depends on the runtime's definition of an event. This palette, the shared behavior that it wants is this ability to emit events. So that's something that we have to kind of configure with the trait configuration trait. And so we know that in this palette, we're going to need some event type. But because we want to keep things really general in Substrate, we want to define that type as a minimal set of capabilities. And so the way we define capabilities, behaviors in Rust is by using traits. And so just like here, we had a colon that separated the traits that this trait is going to be composed of. This colon here, everything that follows is a trait. They're separated by plus marks, concatenated, just like we said the traits up here could be separated by plus marks. And just like these traits are what compose this trait, these traits are what bound this type. This type must implement all of these traits. So now, as I'm looking at this, let's go look. I think the hashing one is a really good one to use. So I say, okay, the frame system needs to know about this hashing type. And there's a description here, which is very useful. Definitely want to read this. The hashing system, the algorithm being used in the runtime. Okay, that's a little weird, but I know that it's described here. This is, I would say, an ambiguous way of describing it. This is code. This is unambiguous. So let's unambiguously look at what this hashing type needs to provide. Okay, so this is a trait. It's provided by this crate. This is a module within that crate. So the crate is SP runtime. The module is traits. And now we're looking at this trait because it's purple, and it's called hash. And so the hash trait has some associated types associated with it, this output type. And then there are some required methods that you have to implement if you're going to provide a type that implements this trait. And then once you implement these methods, Rust and all of the magic that it provides is going to be able to provide these methods for you. So once you define these, and along with this associated type right here, you'll have access to the functions that you defined. You'll have access to the provided methods, and then you'll be able to refer to this type in like a generic way. And so this is all the capabilities that this trait is going to guarantee you. And then we can even come down here, and just like we saw, for instance, Blake 2 is an example of a hashing system. We can see, oh, sure enough, this has been implemented by Blake 2. And let's take a look at the source code there. This is kind of a neat capability of Rust docs. You can use them to view source code. And so now this is a little bit of different terminology here, but you can see we're implementing, yeah, this is big enough. We're implementing a trait, the hash trait, for a type called Blake 2 256. And we have the curly brackets there. And then what we do is we define our associated type just like this. So we're saying the output type we're going to use this concrete type. So this generic not the correct term, associated type. Oops, just knocked my headphone out there. We are going to use this concrete type, this SP Core H256. And if you want to learn more about that, how would you do that? You take this, you copy that, you come into here. I'm going to open a new browser just so I don't lose it. And then you come up here and you just paste that and you start. There you go. Now you're off. You're learning all about it. We're going to use this specific type for that output type. And then here we provide the implementations of the required functions. And so now this Blake 256 type, we have access to the output type, this function, and the provided functions. And actually, let's go back there. Oops. I have to go here. Oh, this one. Back to the hash trait. So you can see that the associated type is used as the return value of these required methods. And so I would say you will always see in normal traits, no, forget what I'm going to say. You will often see these associated types either used as a return value or as a parameter type. That's very common. So like, we're not exactly sure what type this method is going to return, but we know that whatever type it returns, it's going to be bound by these traits. So you can see how this is, you're building up layers and layers and layers of this stuff. And I hope you're starting to see how powerful this can become. Okay, so where am I? Okay, so we are looking at the trait configuration trait that we are defining for the pallet template. And we've kind of understood why we would need to have an event type, because this pallet wants to emit an event that's like shared behavior it needs to have with the runtime system. So it needs to implement that type. And so what's the minimal set of behaviors that we need to specify to make this all work? Well, we can see that there's two, because there's one plus sign there. So that means there's two trait bounds. One of them is from, and one of them is into. I'm going to pause there, see if there's any questions. No questions, cool. Okay, so, okay, let's start by like understanding. Let's go to our Rust docs and see if we can find something about this from trait. Actually, I bet if we just go to event, sure enough, here it is, from. And what I can see is that this is, it's okay, part of the core crate, the convert module. That's really helpful. The convert module, that's helpful naming right there. And so this is from. But let's just go back out and we can see, okay, convert, it's trait conversions between types, from and into. You're converting back and forth between types, and that really makes a lot of sense if you think about it. If we're configuring some event type that we want to share with the frame system so that we can emit events, we want to be able to convert back and forth between our definition of an event and the runtime system's definition of event. So now I hope this is starting to become really much more straightforward. Let's start here because it's kind of the scariest one, but now I hope everything just kind of melts away because the syntax is starting to make sense. And so we can see that this event type, it needs to implement this into trait. And what do we need to convert it into? We need to be able to convert it into an event. Okay, but what type of event will self as frame system trait? And that makes sense because we know that we're composed of frame system trait. And we're going to get the event from the frame system trait. So you know, we kind of have like these single colons here and these double colons here, and then these angle brackets that are being used to separate things. And this is kind of some very, you know, weird stuff about Rust. So that may make it seem kind of scary. But hopefully now it's starting to make sense. Like these single colons here, they're used to define like a trait bound or like composition type thing. And then angle brackets are like it's like a generic type of thing, or like a way of digging down into something. And then the double colon is a very similar thing. It's similar to like a dot in other languages. So whereas in Java, you may say like this dot var, here you're saying like self as frame system trait colon event. And so now this, I mean, this is really starting to make a lot of sense. We can go back, we can look at the frame system trait. We can see that it defines an event type. And so whatever event type my palette is going to use, I need to be able to convert it into the frames version of an event. And the same, then, you know, the from is just the backwards of that. So that's where, you know, kind of understanding like the convert and doing that digging into the Rust docs really helps a little bit. So that is kind of it, essentially. Like that is more or less all of the information that I wanted to get across. So now is the time. If anything here in these 1, 2, 3, 4, 5, we just spent an hour and 15 minutes talking about 5 lines of code. I love it. If anything in this 5 lines of code is not, like, honestly, at this point, like rather crystal clear to you, now is your time to ask that question. And if there aren't too many questions, I can show a little bit more. But let's pause for a second. Aha, questions. I love it. Okay, Mateus. In that hashing example, in that hashing example from docs, returning self-hash as output type is enough to fulfill the requirements. And I also just remembered I had another question I said I was going to get back to, so I'm going to do that. But first, I'm going to answer Mateus's question. In that hashing example from docs, returning self-hash as output type is enough to fulfill the requirements. Not quite. And let's go look and understand why. So we're going to go to, where are we? We're looking for hashing hash. Okay. So it's not just enough to return the type. I think I know that the function definitely needs to have the same number of arguments, and the type of the argument needs to be the same. And I would think that in Rust, the function name needs to be the same as well. So all of these things need to be satisfied: the return type, the parameters, the function name, and then you also have to define the associated type. So just going back to the implementation that we saw, it's not just enough to have this. You need to have all of this. If any part of this was missing and you tried to compile this, the compiler would say, no, you can't do that. You're not implementing hash, because you have to provide, define, specify, whatever, all of this stuff. So let me know if that's not helpful, Mateus. I'm going to answer that for now, and I'm going to go back to the question that I didn't answer entirely, which was this one. Yes. Okay. So actually, this is going to kind of get me into I just want to pause for like at least another second or two, because this kind of gets me into like the more advanced section. Also, like, I'm going to take a sip of coffee, just like a little breather. That was a lot of like heavy, like, technical stuff. It's really foggy here in Southern California, which is nice. Doesn't often, precipitation is not like a common thing in Southern California. So anytime there's water in the air, I get really excited. All right. I don't see any other questions, which is a really good thing. So let's kind of come back here to this excellent question. And let's reopen this. Okay. So we just kind of really dug pretty deeply into kind of, this very basic example of the trait configuration trait. But what if we want to do something a little bit more complicated? What if we want to, as my good buddy Pranshu over here is asking about, what if we want to start like sharing capabilities in a little bit more of a intense, advanced way? So I need to make it clear what I'm about to do, because I am about to embark on a topic that I could talk about for at least as long as what I just talked about. But seminar's not going to go over today. I'm going to kind of like tease you with this little idea, give you guys, the information that you need to research it, and then maybe we can do a follow-up seminar at some point. But what I'm really going to ask for from you guys for that seminar in particular is that for the next stuff that I'm about to talk about for the next 5 to 15 minutes or whatever, is that you really have a lot of questions, and I won't have as much kind of prepared to talk about. And I'm going to share with you guys like a pull request and then a branch of code that at some time may turn into a pull request. That it actually hasn't, just because I've been lazy. And so I would expect you, as kind of like homework or an assignment, like this is maybe like a first for seminar. I am assigning you homework officially, I will say it, is I would really like for you guys to go through these pull requests and the branch and make comments. I go ahead, give you permission. Like, I think I own both of these the pull request and the branch. So go wild. If you have questions, comments, suggestions, you want to talk about coffee, put it there. And then we'll schedule a follow-up seminar and talk more about this. So let's go into what I am talking about now. So it's hard to talk for this long, even for someone like me who has so much practice. Let's just finish up with this. This last paragraph here is basically just me kind of like saying again, like, sometimes you just have to accept what's going on in Substrate and Frame. So again, hope this is helpful. I'm going to close that for now. Okay, so we went through the template palette, which is very, very simple, really to kind of help you understand the basics. And obviously there's a lot more to understand in here. We just went through literally the very first part of this palette. We could have like 3 seminars on storage alone. So that's a whole thing to learn about. Then there's learning all about events. Then there's errors. Then there's all kinds of other stuff. So we really just barely scratched the surface. So there's a lot more to dig in here. But let's now imagine that you're kind of like, okay, you've got the basics down. You're looking to kind of like take it to the next level. I strongly recommend you go to the enterprise sample. Love it. It's a great example of like a substrate application, as I would describe it. So let me provide this link for you. And so getting back to Pranshu's question, we're going to ask ourselves, like, what if we want to do some like more like intense sharing of capabilities? So let's go into our chain. We're going to go look at our pallets. And in particular, we're going to look at the registrar pallet. So we're going into the lib. And remember, I told you that we could have a plus sign after the frame system trait. And you can see here, this actually looks a little different. So just to kind of, we're here to really talk about Rust syntax. So let's just look at this. Earlier, this said frame underbar system, : trait. And you can see here now it just says system. That's weird. Well, that's because up here, we said use frame system, and we said self as system. So system is a reference to frame system. And you can see that we're using these crazy double colons to kind of like dig down into this, just like we may use a dot or something in other languages. So this palette in particular, it doesn't just compose the frame system trait, it also composes the DID trait. And oh man, what is that? What is the DID trait? So we don't see DID listed up here in the imports. So that must mean it's somehow available to us. So let's go back out to the root of this, and we'll go look in the cargo.toml file, which is like, it's the manifest file. So a lot like if you're familiar with Ant, you know, that has a manifest file for Java, or there's like package.json. Cargo.toml is just like the package.json for Rust. And so then if we go out here, oh, here we go. Here's a dependency called DID, and we can see that we're getting it from here. So let's open that link in a new tab. But now that we know kind of what that is that we're looking at, so we'll go back here and we can say, okay, well, this we understand. We just talked about that. But what's this DID thing? Oh, what is that? Okay, well, first of all, actually, one other thing I want to point out as we're kind of understanding how to do all this. Let's go back here, go to the cargo.toml, and see that we're not just using any old DID palette. We're using this 2.0 version. So that means it's going to be tagged 2.0. That's just how cargo works. So let's make sure that we are on the 2.0 tag so that we know that we're looking at the right code. That's really, really important as we're talking about kind of like pro tips or like best practices. Like, you need to always be sure you're looking at and using the right version. So important. So we're going to look at the second version 2 of the DID template or DID palette, and let's go look at its trait configuration trait. So we can see that it has some stuff that it defines, and then it's being composed of another palette there. So you can see how there's kind of like layers of composition. Now, I mentioned that because we're composing here, we're going to have access to everything that the DID trait defines. And so we can look at that trait, and you can see that it's only this and then whatever we may get from the timestamp trait. So we could go and look at that, but I'm not going to do that right now. You know how to do that on your own now. But there's a little something more. And to be honest with you, I don't actually really know why this is. And my guess at this time is that it is what I would call macro magic, but like it's just kind of some of this magic of Frame as a programming language. But when you tightly couple, this is essentially, you can say when you have this kind of syntax in your palette, you are tightly coupling with these other pallets. So all pallets are tightly coupled with the frame system palette or module or whatever. And this palette is tightly coupled with the DID palette. So one piece of this homework that I'm going to give you is this. Obviously, the idea of tight coupling implies the idea of loose coupling. And so this is a good place to start to learn about that. Again, there's homework. This is homework. I'm not going to tell you all about it today. But we are tightly coupling with the DID trait. And one of the things that happens when you tightly couple with a palette in Frame is that not only do you have access to these types, but you also have access to the public API of that palette. And this is not the API that's defined here in the decl module macro. This macro gives you the dispatchable functions, the transactions. You shouldn't think about calling a transaction from one palette into another. So that's not what tightly coupling. So you don't have access to any of this stuff. What you do have access to is this stuff, this impl module block. So when you tightly couple with a palette, one of the things that the frame system is going to do for you is give you access to this isOwner, all these public functions. You can see these are all public functions, which makes sense, again, because we're implementing a trait, and you wouldn't implement a trait with private functions, although I do believe that you can put private functions in here. Yeah, like this is a private function. And so then this would not be available to any pallet that you tightly couple with. It's only available within this pallet. So this is all to say that the reason that you would tightly couple with the pallet is to have access either to some of its associated types or some of these capabilities that it defines down here in its impl module. And so we know that we're coupled with the DID pallet. Let's see how we're using this. Okay, so I'm not going to dig too deeply here, but looks a little scary, but hopefully now you start to have the tools to solve this problem. Double colons are really just dots, and this is kind of just like a generic, basically. So this is a DID dot module that's generic with respect to some type T, which, spoiler alert, it's the trait configuration trait. But double colon, this is like a dot, so we're calling this create attribute function, and then sure enough, we look around. Yep, there we go. Create attribute. This is the exact function that we're calling, and so the reason that we coupled with the DID palette is because that we knew that we wanted to provide the capabilities that the DID palette provides, and there's a specific function on the specific DID palette that we want to call, and so we tightly coupled with that palette, and so that is kind of some more advanced stuff that you can do. But this is not really good. Tightly coupling it's not really a good thing to do. It's like it's something that you do. We had a little convo about this in some of our team internal chats. I'm not saying there's never a reason to tightly couple. If you're just breaking apart pallets so that you don't have a huge pallet, you within your own mind just want to keep your code a little bit more modular, tightly coupling is fine. But if you want to share capabilities, you don't want to tightly couple and rely on a specific function from a specific palette. You want to loosely couple and rely on a trait, because traits are better than, they're more abstract. And so, Pranchu, I hope this is starting to answer your question. How do I call into one palette from another palette? So tightly coupling is one way, but as I was going through this enterprise sample as a Substrate developer trying to learn more, and I saw this tight coupling, alarm bells started going off. I was like, oh, why would you do that? That's not a good thing. This is reuse of code. This isn't just modularizing and separating concerns. This is reuse. This should not be tightly coupled. This should be loosely coupled by way of some trait. So I did code. And that code is on the master branch, I believe, which is why it's important for you to always make sure you're looking at the right thing. And now I'm going to share that pull request with you that I mentioned. Oh, oops, my bad. Okay. So this is the pull request. This is y'all's homework. So look at this, ask questions, take notes, whatever, make suggestions for a future seminar around that. But let's start just looking at this again. I'll probably end up going a little bit over, but I just don't really want to go over too long today, guys. So I'm kind of starting to wrap things up now. So this is a very, I hope, straightforward example of what it looks like to move from a tight coupling where we're relying on specific functions to a loose coupling where we're relying on traits. And so the first thing I have to do is define that trait. So that's one of the things that I did in this PR, and I'm not going to talk about it all. You need to go and do that homework. And then I actually used that trait. So now we're back in the DID palette, and let's see. You can see, let me see, sorry. I know I'm getting a little, here, the diff is making it read a little bit funny, but here you can see, and again, this looks so scary, I know, but just like when you see something like this, just like stop for a second and give yourself a second, and you can do it. It's only angle brackets and colons. You got this, okay? So we're implementing something. It's going to be generic with respect to some type T that implements this trait type. But what we're implementing is the DID trait. And where can we learn about the DID trait? Right up here. This is where it's implemented. This is the trait that we're going to implement. Okay. And now this trait is generic. It doesn't use associated types like some of our other traits. It uses generics. And so let's go look at that and see how that could be. You see here, it looks more like familiar, I would hope. The trait is defined with generics as opposed to like within the curly braces having like a type blank equals blank kind of thing. So that is what these scary things are, you know, just providing those generic types. And now we are implementing this trait for the module, which is the pallet. Maybe that's the next one. Maybe we'll rename module pallet next, who knows? But either way, we're going to implement this trait for the pallet. And so basically what you can see is that basically, I just replaced everything that was in that public API, because it really shouldn't be a public API. It should be an implementation of a trait. And because it's an implementation of a trait, we don't need to specify that things are public, because it's kind of like implied. And then actually that now, as I'm saying that, it makes me understand why this works. So you can see that all that's been left in this old block, this impl module that used to have my public API, and is this private function, this signed attribute. And now I understand the reason why this works is because we're not implementing a trait. We're just implementing the functions for this struct. And so that's why they can be private. And so all that's left in here is the one private function that we don't want other people to use. And so the other thing that I did in this PR that you will notice is that I removed the type coupling from the timestamp trait, and that materialized as an associated type. So that's something that you can look at. But what I'm now going to show you is the updated version of this file that doesn't tightly couple with the DID palette. So I'm going to go over here to my branch, which is called feat DID trait. So it's a new feature related to decentralized identifiers, and in particular, I'm going to use it by trait as opposed to tightly coupling. So let's go to this branch. And I actually find it very helpful to do a diff. I like looking at things by diff. So let's do this. I'm going to copy this. This is just a little bit more kind of like git foo for you guys. So this should actually be pretty easy. So I went back out to the root, and there's this compare thing here. And so this is going to compare. You can pretty easily, we want to see version 2.0 because that's what we were. Oh, no, sorry, faster. Yeah, you can compare the branches there. Sorry, bit of an aside. I'm getting tired, as I said. So this shows you what it looks like to make the changes on the other side of things. So now we're no longer tightly coupled with this pallet. We still are going to reuse the capabilities of the DID pallet, but we're not going to tightly couple with them. And so now you can see the syntax is starting to look a little bit different. So this is the second part of the homework, guys. So Pranchu, that was a very long answer to your question. I hope that it was helpful. That's not the only way to kind of like share behavior in Rust and in Substrate, but certainly with respect to what we were talking about today, that kind of gets us to the next level. So I hope that was helpful. Definitely, if you guys don't understand the homework that I gave you, let me know if you don't understand the homework. Okay. If I were to add this trait, if I were to debug this DID trait while making changes in my code, I would need to compile everything before I could just inspect the contents and the definition. I'm not sure if I understand that question. If I were to debug this DID trait while making changes in my code, I would need to compile everything before I could just inspect. I mean, once you've written it, Rust is a static programming language, so it should be, it should adhere to that. I'm not 100. I mean, of course, before you run the program and debug it, you need to compile it, but just not 100% sure I get the question there. Sorry about that. Please feel free to re-ask. Okay, Spencer's got a question. In order for two parachains to share messages, would they both need to implement the DID palette or any other palette in exactly the same manner, or is it only the trait implementations that matter? Excellent question. It should only be the trait implementations. It's not to say that it won't, as you could see with the enterprise sample, you can write code that's tightly coupled, and then you would have to use the same palette and whatnot. But good frame developers, when the problem is code reuse, the answer is traits. And so one of the things that I'm working on right now in general, as the Polkadot ecosystem is beginning to emerge, I would say, it's not beginning to mature. I don't know if we're quite there yet. It's beginning to emerge. What I would say I'm trying to do is encourage maturity by encouraging people to focus on standards, and those standards should be materialized as traits. So that's one of the reasons why I'm kind of like freaking out, why I'm like, alarm bells go off in my head when I see this tightly coupled palette, because that's not a standards-based approach to development. And the only way to maintain a sustainable ecosystem is to take a standards-based approach. So you should always try to reuse functionality through traits. That is a really, really good question, Spencer. Thank you for asking it. And let's see. Yes. Will Chevdor has some great suggestions there about debugging. I know that I've shared a number of times this link. I'll just go ahead and share it one more time. I'm also, okay, I got another question from Mateus. Okay. You had to go over GitHub to discover the contents of DID before loosely coupling. If I were to use an IDE to actually inspect the definition of I would not encourage you to try to use a debugger to inspect the code to understand things at that level. If you're trying to understand things at the level that what I'm hearing, you want to read the docs or the source code. And if you feel like you're needing to read the source code as opposed to the docs, please let me know, because there probably should be docs for that, but we're just not there yet. But if you're trying to like understand requirements or expectations or these kinds of things that are that traits communicate, you shouldn't be doing this at runtime. You should be doing this in the design phase when you're researching documentation, researching code. Then you kind of put everything together. And now if you're running your code and something is not working the way that you would expect it to work, this is when you start to use the debugger. And at runtime, you start to see, okay, what is the actual value of this actual variable when I do this particular thing? But the whole idea of traits is that you don't need to have an implementation in order to work with them. You only have to understand the interface, and that shouldn't require debugging. Sometimes you just need to check on, I mean, sure, there are debugging capabilities that work with Substrate. Again, if you are trying to understand the parameters that a function takes in general, don't use debugging. That's my suggestion to you. If you really want to use debugging, yes, there are debugging capabilities that work with Substrate. Of course, you need to compile code before you can debug it, and we have shared those links. But I would not encourage you to use the debugger to learn about the parameters that a function expects. You're going to waste your time. Cool. Awesome. Yeah, so I mean, I'll just hang out for like another couple minutes, drink some more coffee, you know, still foggy, so not much more weather to talk about. But yeah, I mean, the other thing, Mateus, is like, I'm just not a very good Rust developer, if I'm honest with you. I'm like I said, I'm an application developer. I'm not a systems programmer. So like, it's just not my gig, you know, learning about systems programming. So definitely listen to people like Chevdor, you know, go out there, research these things. Like I said, it's open source. That's the beauty of open source, is there's so much information out there for you to learn about. And then really, you know, kind of next level is once you learn something that you weren't able to find on your own, now I would say it's kind of your responsibility to put that out there in a way that's easier for other people to find and read and understand. That's what open source is all about, and that's what makes it so fun. So yep, I'm gonna take like maybe another sip or two of coffee, and unless there aren't any other questions, I think that's gonna be it for seminar today. Cool. Thank you, Mateus. Awesome, Chevdor. That means a lot. Thank you. I really appreciate the compliment coming from someone like you. In case y'all don't know who Chevdor is, I mean, I certainly know him as like the, he runs one of our identity, or I think multiple identity registrars. But I think there are many other ways that he contributes to our community. Also, I believe the writer of the famous SR tool, which helps people self-assure that they're doing the right thing when they're interacting with blockchain. That's like the power of blockchain, is that you, as my boss said, Bjorn, I loved this comment that Bjorn made. Google kind of put out this idea of don't be evil, which is great, you know, laudable. Don't be evil. Okay, I kind of call it table stakes, but sure, don't be evil. And what we're trying to move to with Substrate and with the Polkadot ecosystem is can't be evil. I loved that. I thought that was such a good way to put it. And so Chevdor wrote this tool called SR tool, which it allows you to check so that Parity can't be evil, so that, you know, anyone out there can't be evil. And so that's a big contribution that Chevdor has made, along with the many others that he shared. To name a few, I love it. You can hear dry voice. Yep. All right. Awesome, guys. I'm going to go wet my whistle. Thank you so much. I'm glad that this was helpful, and I look forward to seeing your comment. Less trust, more truth. Look forward to seeing your comments, questions on, yeah, those PRs. Next week, we're going to have Will, not Chevdor, but Will, our master of validators, talking about network security. And then the week after that, dude, I was born in '83. So like, I remember when Super Nintendo came out, and it was like the hot new ish. Yeah. Yeah, so then after Will, then we'll have Guillaume on the 19th, and Guillaume is going to be talking about Guillaume is gonna, man, 1980. Okay, that makes a little more sense. I'm like, dude, if you're 80 and learning about this stuff, like, props to you. That is intense. All right. Yeah, so then we're going to have Guillaume on the 19th talking about Frame version 2. And of course, as you can tell, I'll literally just banter until my voice runs out. So with that, I'm going to leave y'all. Happy 2020. Thank you for joining seminar, and I hope you learned a little bit more about Substrate and Rust today.